So today we're doing word problems, systems of inequalities, graphing with Desmos. Our plan was to be graphing with our TI Inspire. However, since you have to be on the school's Wi-Fi in order for the program to be updated and added to your computer, it's just not going to work this week. So, word problems, systems of inequalities. Steps to solve. First, obviously, you're going to read the problem. Second, identify the variables and label using X and Y. Third, we're going to create our linear inequalities. You want to look for keywords such as at least, greater than, or equal to. Is going to be used no more than, at most. That lets us know that we're going to be using the less than or equal to symbol. More than is going to be strictly the greater than symbol. Less than is obviously going to be the less than symbol. Sorry. And then we're going to solve for y in both inequalities. And we're going to use graphing calculator, in this situation Desmos, to graph the boundary lines, and it will shade it for us, okay? To get to the inequalities, you're going to click on the little keyboard at the bottom of your Desmos screen to see inequality symbols. And then we want to give at least one possible solution and put it in terms of the problem, okay? So those are the steps that we're going to follow. So here we have your city's culture center is sponsoring a concert to raise at least $30,000 for the city's youth service. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, how many of each type of seats must be sold? Okay, so the first thing was to read, and we did. Second thing is to identify our variables. So we're talking about balcony seats and orchestra seats. So if we let balcony, so X equals our balcony seats, and Y equals our orchestra seats. Okay, and then once we've established that, we want to create our inequalities. So it says you need to sell at least. So if we go back and look at our keywords, at least told us that we would be using the greater than symbol, right? So I need $20 per balcony and $30 per orchestra to make at least $30,000. Okay. It says if the center has 500 orchestra seats, how many of each type of seat must be sold? So I have a cap on my orchestra seats, right? So I know that Y has to be either less than or equal to 500 because there's a cap. So this is my system. How do you feel about setting up the system? No questions? Pretty good? All right. Then the next thing we're going to do is step 3, which is step 4 is to make sure that each part has Y by itself. Well, this one's good to go. Y is by itself. This one right here is not, so we're going to get Y alone. So we have 20X plus 30Y is greater than or equal to 3,000. So we're going to subtract 20X. And then we're going to divide by 30. So that leaves us with Y is greater than or equal to, and we have 3,000 divided by 3 is 1,000. 20 divided by 30 is negative 2/3 X. So that's what this is. All right, then our next step tells us that we're going to graph this using our graphing calculator. And our situation, we're going to use Desmos. Click on this to open my Desmos. See how prepared I was already like, boom, bam. All right, and then we're going to input those values. So we have, when you're inputting, we're writing Y. And to get the inequalities, you click on the keyboard down here. And so Y is greater than or equal to 1,000 minus 2 divided by 3x. Okay, I'm going to put in the second one, y has to be less than or equal to 500. Okay, now there are other restrictions. The other restrictions come from us knowing that because this is a real world problem, a couple other things have to be true also. We know that y has to be greater than 0 and x has to be greater than 0, greater than or equal to 0, because this is a real world. So when we're looking at this, we're going to zoom in and zoom out here in a minute. So right here, if you click this home button, it's going to be on the default zoom. And then once from the default zoom, you can start zooming out till you see your graph, and just by zooming. And then if you click and drag, that allows us to put in our final constraints, which means that we're only dealing with positive x's and y's, which means our solution is only in quadrant 1. So our x values have to be greater than or equal to 0, and our y values have to be greater than or equal to 0. Okay. Now, for your assignment today, when you are doing this, let me log in really. Log in super quick. When you're done, a part of your assignment is to submit your graph. To submit the graph, you're just going to click on this little share graph button, and you're going to export the image, and it'll download it to your computer. Okay, and so then you can hit download, and then save it wherever you're going to save it on your computer. Okay. But back to our problem. So here's our solution. Our solution is where the two colors, where the red and the blue make purple, right? Where they overlap. And so here we can decide on a value that would work. Okay. So choosing a value that would work in this space. Anything in this space that is greater than y greater than 0 is a valuable solution, right? For the most part. Being mindful that orchestra seats are only 500. So if I look here, I can choose, let's see, what value? So we're counting by hundreds, 1, 2, 3, 4. And over here, we're counting by thousands, hundreds also. So what if I said I did 400, so 11, no, I'm sorry, yeah, 1100 and 450. Or I could just do the intersection because it's equal to. So if, let's say we choose the intersection one. Say I do 750 and 500. That works too because I have a maximum of 500 orchestra seats. Your solution just has to come from within the purple. I hope that makes sense. So it's coming from within the purple where they overlap. So right here, let's do 1,400. So if I say my values I'm going to use are 1,400. So if I let x equals 1,000 and y equals 400. And I substitute these values in, is 400 less than or equal to 500? Yes, so that system is satisfied. If I plug these values into here, is this system satisfied? So 1,000 times 20 is going to give me 20,000. 400 times 30 is going to give me 12,000. And 20 plus 12 is 32, which is greater than 3,000. Okay. And so as long as they satisfy, then that's my answer. So I could write 1,000 balcony seats and 400 orchestra seats as a possible amount that could be sold. Okay, now if I wanted to sell all of my orchestra seats, then that's where I would use that 750, 500. So if I wanted to sell all of my orchestra seats, then my option would be 750 balcony seats and 500 orchestra seats. And that would also satisfy the situation. So everyone's answer is not going to always be the same. Because there are multiple possible answers. Now, if you give me an answer that involves a decimal or a half point in this situation, that wouldn't work because you can't sell half a seat or a third of a seat. Only the whole values would work. So again, we looked at the graph. I just wanted you to see that in this space below x, y equals 0, we couldn't use any of these values. Okay, and because we can't use any of these values, it won't, because they'll create negatives, and you can't have negative seats either. All right, any questions so far? How do you feel about using Desmos to do the graphing? Pretty good. All right. We have a pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? Okay. So again, we're going to establish our X and Y. So we have vegetable toppings and we have meat toppings. We can let X equals our vegetables, and we can let Y equals our meat. Okay, then from here, we're just going to create our system. So reading the first sentence, there's $1 for each vegetable topping and $2 for each meat topping. So we have 1x plus 2y. And in this case, money with money. So if I'm talking about money, I have a limit. I have only $10 I can spend. So I can spend either less than or equal to $10. Okay. And then I also have a specific, I want to get the most bang for my buck. I want at least 5 toppings on my pizza. So I know that X plus Y has to be greater than or equal to 5. Now, I know none of you probably have sat around and thought about, how can I get the most out of my pizza? But this is how you can get the most out of your pizza. So we created our system. And now we're going to keep going. So we created our system. The next step is to get the Y's by themselves. So if I need to get Y by itself in this one, I'm going to have to subtract X and divide by 2, right? So we know that Y is less than or equal to 10 minus X divided by 2. In all honesty, because you're putting it into a calculator, this can stay like that. You don't have to simplify it unless you want to simplify it. So if you want to write this as 5 minus 1/2 X, go for it. But you can leave it as so because it's going to simplify it in the calculator. Next, I'm going to get Y by itself here. All I have to do is subtract the X to get Y by itself. And that's going to lead me to Y is greater than or equal to 5 minus X. Okay. And then now I am ready to go ahead and graph. So I'm going to graph. Here's my graph. I'm going to type Y, and we have is going to be less than or equal to. To get the fraction, you're going to use parentheses. So you're going to put the numerator in parentheses. So we did 10 minus 2, minus X. Close parentheses, divided by 2. So there's my first, and I'm going to hit enter to put in my second. And on my second, I have Y is greater than or equal to 5 minus X. And then when I'm done, I just minimize that. And again, unwritten restrictions are X has to be greater than 0 and Y has to be greater than 0 because these are real world problems. So I can go ahead and just kind of drag it to satisfy those. And my solution lies in the purple, right? So somewhere in this purple, I can decide what I'm going to do in order to spend my money. So if I'm reading this, I have all these choices and possibilities that I can select from. So if you look right here, I can go with, it's counted by halves, yeah. By 2. So here at this point, I have 0, 5. And what did our Y represent? That was our meats. So I could do 0 vegetables and 5 meats, right? If I come down here, I'm at 5, 0. I could do 5 vegetables and 0 meats. If I come here, I could do 10 vegetables and 0 meats. That would be the maximum I could do on that one. And so I can choose anything in here that's going to work. But remember, you only can choose points that are whole because I don't have halves. So here, looking at 1, I could do, nope, that's a half. Here's 2. So, nope, that's not, I'm not on 2 yet. Those are all half points, half points, half points. Oh, there's 1, I'm sorry. I could do 1, 4. So I could have 1 vegetable, 4 meats. At 2, I could be 2, 3. So all of these are possibilities of what I can do and what I can have on my pizza. And so any of these to give an answer would be correct. Okay, so how many of each type of toppings can you get on your pizza? Well, here we go. So looking at our graph, we have 5 meats and no vegetables. We could do 4 meats and 1 or 2 vegetables. So 4 meats, I can have 1 or 2 vegetables. We could do 3 meats. So if I go to 3 meats, I can have 2 vegetables, 3 vegetables, or 4 vegetables. I can have 2 meats. So if I go, sorry, I'm going the wrong way. 2 meats is this way. I could do 2 meats, and if I do 2 meats, that's going to put me at, I think I did my graph backwards. No, I did it fine. I did. I switched the vegetables and the meat on this one. My bad, y'all. But this would be the gist of it. It's just reading the points, and if you want no meat, you can have 5 to 10. And it just keeps going. I don't know what graph I put there. Oh, I did. I did it when I graphed it. I used my vegetables as 0. Got it. I did. I switched my X and Y when I did the notes. I think I did that because I would have Y and not have to divide. Now I know. So here, for this problem that I have here, I'm sorry, I made my X equal my meats and my Y equals my vegetables. And the reason why I did that was because vegetables are already $1, so there wouldn't have to be any division. It was just subtracting to get the Y by itself. I remember. But yeah, so all of this comes from just what's in the shaded region. So this, and that's in the quadrant 1 because it's real world. So that's where my possibilities come from. All right, how are we feeling? Like, is it doable? Are you like, I don't think? Feeling good? Thumbs ups? Something? Nothing? Okay. All right, and then our third example. You can work a total of no more than 41 hours each week at your job, at your 2 jobs. House cleaning pays $5 per hour, and your sales job pays $8 per hour. You need to earn at least $554 each week to pay your bills. Write a system of inequalities that shows the various numbers of hours you can work. Okay. So again, we read, then we're going to establish what's X and what's Y. So I let X equal my house cleaning job, and I let Y equal my sales job. And I can work between the two no more than 41 hours each week, right? So I know that X plus Y has to be less than or equal to 41. And I get paid $5 as a house cleaning, and I get paid $8 as a sales job. So I know that 5X plus 8Y is my income. But I need to make at least $255 each week to pay my bills. At least. So this needs to be greater than or equal to 254. And there's my system. Okay. So system made. I now need to get Y by itself. So to get Y by itself, for this one, I just have to subtract. So this is going to become Y is less than or equal to 41 minus X. On this one, I'm subtracting 5X and dividing by 8 to get Y by itself. So Y has to be greater than or equal to 254 minus 5X divided by 8. Now I have my system written with Y isolated. So now I'm going to go to graph. So when I come over here to graph, I end up with, let me open my keyboard. Y is less than or equal to 41 minus X. And then I have Y is greater than or equal to, and I have a numerator, so 254 minus 5X close divided by 8. And there's my graph. Now, I'm going to have to zoom out because I can't see it. So zooming out and putting in my real world boundaries, which means that X has to be greater than or equal to 0 and Y has to be greater than or equal to 0, which puts me in quadrant 1. All right, so my solutions, my possible solutions are in where the two colors overlap. My two colors overlap from here to here. So if I wanted to earn that amount of money, I could choose any point in here and go from there. So if I work, let's say I chose this point, and I put 10, 30. So the 10, 30 is telling me that if I do 10 hours at housekeeping and 30 hours at sales, I will have money to pay my bills. Okay, so if I put these into the original, and I'm working less than 41 hours, and so that will be 50 plus 240, and that gives me 290. Okay, so that's it. So you choose a point that you can interpret and use. I could do 15. So 15 in 2, 4, 6, 8, 26. So I could do 15. I'm sorry, not 15. 12. 12 and 26. 12 and 26. So you get to choose what point you want. Okay. All right. So then we wrote the system, and then you can come up with. So what did I just say? I just had 10 and 30. If I work 10 hours house cleaning and 30 hours in sales, I can pay my bills, right? And that would be it. But I want to remind you that there are various answers within this region. So what I choose is endless possibilities. Well, it's not endless, but there's plenty of possibilities in between these areas. So your answer may not be the same as the next person's answer. All right, so that concludes that. So now that we've gone through that, you have your work for today. So your work for today is a choice board. So for the choice board, you're going to choose 3 of the following word problems to complete. So whatever 3 you want to complete, you're going to write the system of inequalities after you identify your variables, just like we did in our notes. Then you can use Desmos to graph the system. And then you're going to make sure, oh, the little button, make sure that you're downloading the graphs. And then you're going to choose 2 points that satisfy the system and write it in how it pertains to the problem, i.e. 2 pens and 4 pencils, okay? So you have 12 to choose from, and you just got to choose 3. And that's it. Any questions?